I'm Kim.
And I'm Matt.
So basically what we are looking at is the different ways that scientists use to track animals. So there's kind of from the very simple, which is kind of the differences between the way species look, which is what this activity is, whether or not you can distinguish between them. And then you have species which you can't necessarily find, or that are sort of that one's frogs, and they are away in the day and they're in the ponds and you can't see them. So for that one you use the calls and you listen to the different call files from the locations. And then for that one we have the feces, which is left behind, sort of anything that is out at night that you wouldn't necessarily see. You may, especially mammals, you'll be left behind with feces, but that might be the only sign you've got. So being able to identify them based on that. And then for the last one, we have for things like, so the example we've used is fishing. So commercial fishing, the fish are cut into fillets out at sea, so you can't identify what's brought back based on that because it's just a fillet and it could be anything. So you have to use indirect methods, so we use things like DNA, and that's what that activity over there is, so using the DNA to tell whether or not what you've caught is an endangered species.
Tracking is used in sort of all areas of science basically. So if you're tracking, I don't know, galaxies moving like around the universe, or if you're tracking tiny little cracks in materials, it's just useful in all areas of science. So we thought the most sort of visually appealing one is just animals. But it's basically to give an indication that tracking is used in all areas of science, from conserving nature to cancer research. They use tracking of cancer cells around the body and that sort of thing. It's really good for young people and kids to know what they can do and what possibilities there are in science. Because quite often, maybe at school, there's sort of your different like biology, chemistry and physics. It's maybe not very exciting, but you don't know that if you do chemistry, you can end up doing sort of conservation like this, or if you do physics, you can end up doing sort of engineering or material science, or you don't really know what you can do from these subjects. So it kind of makes it more tangible. So I think that's really important.